Welcome to A-Level Further Mathematics Mechanics 1, and today we're going to do some resolving forces, and this is one of the topics in mechanics, and it's one of the most fundamental parts of mechanics, so let's start. So here are some concepts. So for every single force, it will contribute a force in mostly two directions. It actually exerts a lot of force in different places. Well, that would be explained a bit better in the examples because it's a bit confusing right here, I think. And it doesn't exert any force perpendicularly, but it does for any degree less than 90 degree. So next up, it's one of the most used things in mechanics. Even in mechanics 2, 3, and 4, you do use resolving forces to find the answer to questions. So yeah, let's do some example questions. So there aren't really a lot about this to talk about because it's quite simple, and as we have said, it's abusing trigonometry to our advantage. So in this case, we can draw a line through here and a line down here. They should be straight lines because it's, if drawn to scale, this is on computer again, so that is not right. And now we have two triangles, and these are 90 degrees and opposite angles. Now we've got right angle triangles. We know that this diagonal is 10 newtons. And if we want to find A, what we do is use trigonometry that use an adjacent side and a hypotenuse side, which is cosine. So that would be cosine 20 will be equal to A divided by 10, and which A can be written as 10 cos 20. And this is one of the ways of writing out a resolved force. Is a general equation will be the resultant force labeled F, then sine or cosine, and that would be a theta sign, which, if you want to know how to type theta in Word document, it would be O3B8 and alternate X. So that is the theta sign. So yeah, this is one of the most used way of describing a force. By resolving it, you just use trigonometry and get the force you're using times the resolved angle, and depends on whether you are going towards the angle. I'll explain that later in another section. And for the other side, we know that because these two are parallel, although it doesn't seem like that, this is actually the same as this. So this is 20 degree, and we can do the same thing to get B. And B is this particular arrow, and what we do is opposite and hypotenuse, which will give us sine 20 degree equal equal to b over 10. And we can again say that b is equal to 10 sine 20 degree. And again, it fits on the pattern f sine theta. And now we can get the result by just clicking your calculator. So do your calculation, and I will see you in the next section. So by the time you are doing this, you should be thinking, is there an easier way to find these resolving angles? Because it's really confusing to draw triangles, and by the time you're doing all the exam questions, you'll find yourself drawing millions upon millions of arrows that you really don't need to draw, and that would be really ridiculous. So here I'm going to share a tip with you, and I'll use a red arrow to describe what I'm talking about. So note I used theta and the force, and now we need to resolve either A or B. So when I want to resolve to A from F, simply draw an arrow to here to demonstrate when F goes to A. Then you can see this action is actually crushing the theta. So that would be, if you do the triangle method, you'll see it's a cosine. So when you do the crush theta, you'll find that the result of that resolving will be F cosine theta. And if you go the other way, you go from F to B, then simply it is you're stretching the theta apart. So that would be simply means stretching will be equal to F sine theta. That would work for any resolving problems and steps. So that is one quick and easy trick for you to remember how to resolve. So now let us do some questions. So here are two questions, and I probably need to make my presentation a bit better. So this is quite simple to understand, and the other one is not that simple. It's quite complicated for the second one. And for these two questions, you have to apply the resultant force chapter and this chapter to find the answer. And yeah, you have 5 seconds to pause the video, and also give your answer with a force diagram, please, because that is how you should be doing these questions. If you're just trying to do it in your brain without drawing a force diagram, it's going to be really messy, and it's going to get your head messed up really quickly. So do draw the force diagrams and note the crushing and stretching of angles for sine and cosines. So 5, 4, 3, 2, 1. So I have 2 force diagrams drawn for each question, and they are basically what the question asked. For this, it's you have a inclination force 25 degree with 7 Newton magnitude, and you want to find the horizontal force, which is this force. So what you do is you go from top down and you crush the angle, so you are using the force crush angle or cosine angle, so it's 7 cosine 25, which is on your calculator 6.34 to 3 significant figures. And for this one it's a bit more tricky, and what you need to do is to do an equation because we can't really resolve from this angle to that angle. We have to resolve F to 10 newtons. So we know that the answer would be 10 newton if we F sine 20, because we're stretching the angle this way. And so we can rearrange that to 10 over sine 20, which is 29.2 newtons, which is not this one, but the force. And after we've got that, we need to find the upward force or the northward force, and that would be simply F, then crush angle, so it's force cosine 20, and we just substitute this value into your calculator for the exact value, and we should get right around 27.5 newtons as the answer right there. So that is it for Mechanics 1, resolving forces. If you've learned something, please leave me a like and comments below, and yeah, I'll see you next time.